friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 90. In the last video we saw linked as set. In this video we are going to discuss about sorted set and other sorting interfaces and classes. So let's first understand what is a sorted set. It is a child interface of set. If you want to represent a group of individual objects according to some sorting order and duplicate are not allowed, then we should go with a sorted set. Now I have a requirement. I want to represent a group of individual object. Okay, I want to store multiple object, and those objects should be store sorting order, and those objects should be unique. Okay, these two things, object should be unique and store some sorting order. Here sorted set provides some methods. Let's check those methods. Object first, this return a first object, then object last, this one return a last object, then sorted set head set, this return, here we pass a object, and this return a the all element are less than, whatever we pass all less than that object element it will provide. Then second sorted set tellSet, it will provide a all greater than element. Then next one is a subset. Here we pass a two object, here we pass a two object, and it will return a all the element. Okay, it will check a greater than and less than, and it will return a between those two object all record. Then here we have a comparator. Comparator actually using for a compare two object. Here internally sorting, here storing a data in some sorting order. That's why here need to compare two object. When it's possible sorting, when we compare two object, which one is the greater and which one is the less, here we need to compare these two objects. That's why here use a comparator. And all this sorting all these interfaces and classes only we can store here homogeneous data type, homogeneous object. Here we can't accept heterogeneous. Okay, that's remember, here we can't store a heterogeneous, because in a homogeneous we can compare two object, but if you pass a heterogeneous, then heterogeneous can't able to compare two object. Okay, that's why here only allow homogeneous data type. Okay, remember this thing. Navigable set, and here we have a navigable set. And one more thing, this sorted set, here null value not allow. We can insert a null value, but we can insert only first position. You might be thinking, why first position? Let's consider, if we compare any data type, if we compare any value with a null value, then it will throw null pointer exception. But when we inserting a first element, at that time it will not perform a comparison. But when we insert a second element, at that time it perform a comparison, and there if this comparator method get null value, then it will throw null pointer exception. Okay. Then here we have a second one, navigable set. It's a child interface of sorted set. This interface provides a navigation for an element. We use a navigation set for a navigation purpose. Navigation means we can move forward, we can move backward. That's the navigation. Using a navigable set, we can navigate the set reverse order compared to the order defined in a sorted set. In a sorted set, only have a by default only we navigate in a forward order, but here we can navigate a reverse order also. Navigable set, using a navigable set. Then here we have a finally implementation class. We saw here two interfaces, sorted set, then navigable set, and here finally we have this implementation class, because we can't create a interface object. That's why here we have a one implementation class, that is nothing but tellSet. It's a navigable set implementation class. It's this tellSet is implemented this navigable set. The underlying data structure for a tellSet is a balance tree. Internally it's using a balance tree. Okay, whenever we store any record in a tellSet, okay, tellSet, whenever we store multiple element, at that time it internally follow this balance tree, and by using this balance tree it follow insertion, or we can say it follow ascending or descending order. Here duplicate objects are not allowed. We already discussed in all set interfaces and their child interfaces and all implementation classes not allow duplicate. Insertion order not preserved, but element store in a some sorting order. Here insertion order is not preserved, but here if you don't provide a custom sorting, then it will by default internally sort in a natural order, or we can say some insertion order. Heterogeneous objects are not allowed here because here comparison is required, and only if same data type object have, then only we can compare two object. Here if we store one string and second integer, then it will not possible, it's not possible to compare these two object, which one is a greater and which one is a less. That's why here heterogeneous data type, heterogeneous object not allowed. Here null insertion allowed, but if you insert a single element, then okay, here null we can insert a null, okay, but if we want to insert only single element, because when we insert a first element, that time comparison method not call, because there have only one element, that's why no need to call a compare method. But when we insert a second element, that time comparator method call, and that method find one null value and one some other value, and whenever we try to compare, we try to compare any value with a null value, then it will throw null pointer exception. Okay, here you can see this balance tree, and here we use some ascending order. Okay, here we use a insert ascending order, and you can see here 4 5 8 11 12 17 18 we store this all data, and this all data stored in a ascending order. And you can see is this balance tree also store 4 5 8 11 then 12 18 7 17 then 18. Okay, we will not discuss all this internal process, because I am planning to create a separate playlist for a data structure, and there we discuss all algorithm and all searching, sorting algorithm, all this we will discuss there. Let's open a Eclipse, and I'll show practically how can we perform all these things. Let's create a new class. Here I'll simply create a part 90, and here create a main method, and inside a main method first we check what inside this sorted set. Okay, that's why first create a sorted set and open this declaration, and let's check here how many method present. This sorted set introduced in a 1.2. okay, this sorted set extend this set interface, and here you can see, let's check how many method present. Here you can see subset, head set, tail set, first, last, split, iterator. Okay, let's check this one is introduced in a 1.8. okay, we will discuss all 1.8 feature in another playlist, because lot of their major changes happen in Java 1.8 version. Okay, so next one is the navigable set. Okay, you can see navigable set. Let's open this navigable set is a child interface of sorted set, and this one provides some navigation reverse order also. You can see here descending order, and also some, here we can, by using this navigable set, we can sort our record by using a descending order also. And here you can see here don't have an ascending order, because by default it's follow ascending order. But if you want to store some other order, then we use this descending order. Okay, so here this all feature provide this navigable set, and this one is introduced in a 1.6. Then finally we have a tree set. This tree set is a implementation class. You can see this one is a class, and this tree set extend abstract set and implement navigable set, and this clonable and serializable, this thing is a common for all collection classes. And you can see here we have a lots of method present inside this class. Okay, this all method came from parent interfaces. Okay, so let's create an object, and I'll simply create this string, and let's save here ss equal to new tree set, and here we store some random data, and let's try it will follow any sorting order or not. Let's add here ss dot add, print this object. I'll simply 𝗧𝗢𝗍𝗧, then print this object. This object is a ss. Let's save this, run this, and here you can see 𝗍𝗢𝗟𝗟𝗢. Okay, by default it follow ascending sorting order. Now I want to sort this record in a descending order. Here you can see this navigable set. This navigable set provides this method descending set, or you can say descending iterator. Now I can use this descending set and I can store that new sorted data in a new object, and I can print directly that data. Okay, let's print here 𝗧𝗢𝗍𝗧 and ss dot descending set. Okay, let's save this and run this, and here you can see this, here we get a descending order data. Here just this method descending set. Okay, let's check this method, this head set, tail set, this first, last. Okay, quickly check all this method. I'll simply check this all method 𝗧𝗢𝗍𝗧, then ss dot first. Okay, first, then I'll print all this method, and then we will check finally output, then last. Let's save this and check what output we get. Here you can see first one is a. Okay, after sorting, first one is a, then last one is a w, then here we call a head set, that means all less than. Okay, here b and less than b, here we have only one element a. Then here we use a tail set. Okay, b tail set provide a equal to and greater than element. Okay, it equal and greater element, this b and h w. Then here we use a here we use a subset. Simply provide a between a data. Okay, here you can see subset b and h. Okay, subset provide a greater than obj and less than obj. Okay, let's see. Then finally here we have a this one subset, and here we directly print a object. Okay, and here we print a object in a descending order. This all method, by using this all method, we can perform a sorting operation. We can sort our data according to our requirement, insert ascending or descending order. Here few more things have a related sorting. We can use a comparator, we can use a compare method. Okay, we will see all this thing in a next video. Till that, bye bye.